Okay, in a previous video, I demonstrated that the sum of the interior angles of a polygon is simply a matter of determining how many triangles you can break up that polygon into. That determines the sum of the interior angles. Because you figure out how many triangles you can break the polygon up into, and then you multiply that number by 180. Here we have a hexagon, 6 sides. 6 sides means you can break the triangle up into 4, break the hexagon up into 4 hidden triangles, and each of those 4 hidden triangles has 180 degrees inside it. So the number of triangles that are hidden inside a polygon is always 2 less than the number of sides the polygon has. And so there's your formula for the sum of the interior angles of a polygon. Okay, now we want to investigate the sum of the exterior angles. And let's start with a triangle, irregular, just some arbitrary triangle. Okay, and the exterior angles, I'm going to form the exterior angles by extending the sides in pinwheel fashion. Okay, so I've got 3 interior angles and 3 exterior angles. Let's call the interior angles A, B, and C, and we'll call the exterior angles X, Y, and Z. Okay, well, we know already that A plus B plus C is 180. And we also know that what's A plus X? A plus X, those form a linear pair, so those 2 angles are supplementary. Same with B and Y, another linear pair. And C and Z, another linear pair. So I've got 3 linear pairs. Each of those linear pairs is supplementary. And so all 6, the exterior angles plus the interior angles, is 180 times the number of vertices, 3. Because every place you have, every vertex is going to have a linear pair, and so the number of vertices times the supplementary number at 180 is going to be the sum of all of the exterior and interiors combined. Now, well, what's the sum of the interior angles? Interior angles equals 180. And I'm using abbreviation. This is not really good math notation. Interior angles doesn't equal, I should say sum, is 180. Well, so what does that leave for? So if this guy here is 180, the interior angles is 180. Let me do some color coordinating so it makes it so absolutely clear. Some of the interior angles is 180, like those dots. So what plus 180 equals 3 times 180? That will be 2 times 180. So that leaves 2 times 180 for the exterior angle sum. Sum of the exterior angles is 2 times 180. So I'm just going to write 360 in there, or I'll type it because it's cool and I can't see a table. Come on. 360. I don't know why. Oh, anyway. Ah, okay. Now let's check out a quadrilateral. All right. I might want to save some of that stuff down there. I'll hide it for the moment so it's not distracting. Random quadrilateral. All right. So inside we've got A, B, C, and D. And on the outside, we'll put, we'll put W, X. Well, actually, no, we don't really do. And I can use the same equations as before. We'll put X, Y, Z, into W. And then I can just use some of these equations. A plus B plus C plus D. Oh, remember from the interior angle sum, A, B, C, D. Remember, we could break this, we can break that up. We can break that quadrilateral up into two triangles. So A plus C plus D plus E, sorry, A plus B plus C plus D is 2 times 180. Okay, now, so the interior angles, I'm going to change that to 2 times 180. All right. Now, I'll just hide that for a second. Okay, now, A and X. AX, B and Y, C and Z, they still form linear pairs, but now I also have D and W form a linear pair. D plus W equals 180. So all the angles, interiors and exteriors combined, oh, surely. The interiors and the exteriors combined, oh, heck. There are 4 linear pairs there. So it's 180 times 4. And we just said that the sum of the interior angles was 2 times 180 because you have 2 hidden triangles in there. And if all of the angles, interior and exterior, are 4 linear pairs, then you've got 2 times 180 left for the exterior angles. So guess what? It's 360 again. Now let's investigate I'm just going to go ahead and jump to a crazy one. Let's do, wait, shoot. Let's do some crazy number of sides here. Tools. 1, dun, dun, dun. All right. You've got 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. I have a heptagon or a septagon here. Okay. The interior angles are going to have, how many hidden triangles is it going to have? The interior angles well, there are 1, 2, 3, 4, 5. So the interior angles sum is 5 times 180 because it's a 7-sided polygon. So there are 5 hidden triangles inside times 180. Now, what about the interiors plus the exteriors combined? Interiors plus exteriors. Let's take this equation. Interiors plus exteriors. I'm going to make the sky blue again, or red again, rather. So interiors plus exteriors is going to be, how many linear pairs does this heptagon have? It's got 7 vertices, so it's going to have 7 linear pairs. okay, the interior angles, that's 5 times 180. And interiors and exteriors, you've got 7 linear pairs. So what does that leave for the exteriors? It leaves 2 times 180. So it appears that no matter how many sides the polygon has, the sum of the exterior angles, you're always going to have 2 times 180 or 360. So it's just 360 across the board. The sum of the exterior angles of any polygon is 360 degrees.